Dear student, today we are starting coordination compounds of chemistry class 12th NCERT chapter 9. Do you know what is dative bond or coordination bond? These bonds in which a electron rich entity share its lone pair to electron lack entities. Here transition metals form a large number of complex compounds in which the metal atom are bound in number of anions or neutral molecules by sharing of electrons. These are called coordination compounds. For example, chlorophyll, hemoglobin and vitamin B12 are coordination compounds of magnesium, iron and cobalt respectively. What are the uses of covalent coordinate compounds? It is used in metallurgical process, industrial catalyst and analytical reagent. Its application also appear in electroplating, textile and medicinal chemistry. Werner was the first Swiss scientist who discovered these typical compounds by experimenting a series of compounds of cobalt third chloride with ammonia. It was found that some of the chloride ions could be precipitated as AgCl on adding excess silver nitrate solution in cold, but some remained in the solution. What he concluded? Somewhere he found 3 mole of AgCl, somewhere 2 mole of AgCl or 1 mole of AgCl. It can be concluded that where 3 mole of AgCl, 3 chloride ions are precipitated out, 2 mole of AgCl, 2 chloride ions are precipitated out and 1 mole of AgCl, 1 chloride ion is precipitated. What was his conclusion? The first is cis groups in all, either chloride ions or ammonia molecules or both, remain bonded to the cobalt ion during the reaction. The compounds are formulated as shown in table 9.1, where the atoms within the square bracket form a single entity, that is complex, which does not dissociate under the reaction condition. Means different atoms or molecules or any entity attached to the central matter atom does not dissociate but remains as one entity only. Werner proposed the term secondary valence for the number of groups bound directly to the metal ion. In each of these examples, the secondary valencies are 6. Main postulate of Werner's theory. In the coordination compounds, metals show two types of linkages, that is valencies, primary and secondary. In big bracket, we write secondary valencies and outside it a counter ion or primary valency. The primary valencies are normally ionizable and are satisfied by negative ions. The secondary valencies are non-ionizable. These are satisfied by neutral molecules or negative ions or electron-rich entity. The secondary valence is equal to the coordination number and this is for a metal. Next, the ion groups bound by the secondary linkages to the metal have characteristic spatial arrangement corresponding to the different coordination number. Here we will study only octahedral and square planar or tetrahedral arrangements. He further postulated that octahedral and square planar geometrical shapes are more common in coordination compounds of transition metal. Here some examples are given in the book. The coordination number 6 always follow the octahedral spatial arrangement, while coordination number 4 are tetrahedral and square planar respectively. A different concept between double salt and complex is both double salts are as well as complexes are formed by the combination of two or more stable compounds in stoichiometric ratio. However, they differ in the fact that double salts such as carnallite, KCl, MgCl2.6H2O, Mohr salts, FeSO4.NH4 potassium KAlSO4 etc. dissociate into simple ions completely when dissolved in water. However, complex such as FeCN6 of K4 FeCN6 do not dissociate into Fe2 plus ion or Cn minus ion. Here are some important terms pertaining to coordination compounds. The first is coordination entity. A coordination entity constitutes a central metal atom or ion bonded to a fixed number of ions or molecules. For example, COCl3 parenthesis NH3 whole thrice is a coordination entity in which cobalt ion is surrounded by 3 ammonia molecules and 3 chloride ions. Second, central atom or ion. For example, the central atom or ion in the coordination entities NiCl2 H2O whole 4, COCl NH3 whole 5 2 plus ion and FeCN6 3 minus ion are nickel, cobalt and iron respectively. These central atom or ions are also referred as Lewis acid. Do you know the Lewis acid? Lewis acid are those which accept a lone pair. Third is ligands. The most important. The ions or molecules bound to the central atom or ion in the coordination entity are called ligands. These may be simple ions such as Cl-, small molecule molecules such as H2O or NH3, larger molecules such as CH2CH2, NH2 whole twice, or N CH2CH2 NH2 whole thrice, or even macromolecules such as protein. When a ligand is bound to a metal atom through a donor atom, as with chloride ion, water molecule or NH3, the ligand is said to be unidentate. Here water molecule and ammonia both have a lone pair. When a ligand can bind through two donor atoms as in H2N, CH2, CH2, NH2, ethane 1,2 diamine, or C2O4 2 minus, that is oxalate ion. The ligand said to be dientate. The site is in ethane 1,2 diamine. Two N atoms can donate electrons, while in oxalate ion, two O atoms can donate a pair of electrons. The ligand is said to be dientate, and when several donor atoms are present in a single ligand, as in NCH3, CH2, NH2 whole thrice, the ligand is said to be polydentate. Polydentate ligand. Ethylene diamine tetraacetate EDTA 4 minus is an important hexadentate ligand. It can bind through 2 nitrogen and 4 oxygen atoms to a central metal ion. When a di or polydentate ligand uses 2 or more donor atoms simultaneously to bind single metal ion, is said to be a chelate ligand. Number of such ligating groups is called the denticity of the ligand. Such complexes called chelate complexes tend to be more stable than similar complexes containing unidentate ligands. Means when chelate formation occurs, it is most stable condition. Ligand which has two different donor atoms and either of the two ligates in the complex is called ambidentate ligands. Example of such ligands are the NO2 minus ion and SCN minus ion. NO2 minus ion can coordinate either through nitrogen or through oxygen to a central metal atom or ion. Similarly, thiocyanate ion can coordinate through the sulfur or nitrogen atom. Few more technical terms we will discuss in our new video. Here you can practice and learn ligands structure to continue your full chapter. Subscribe, like and share for more videos. देखते रहें, सब पढ़ें, सब बढ़ें, इसलिए आप इसको प्लीज़ शेयर करें और अपने फ्रेंड्स को जोड़ें. थैंक यू.